when you see these equations and they're already written in standard form, that's what this is. Remember, the x's and the y's are over together. I can't graph it. I can change it into y equals and graph it, but I can't graph it the way it looks. But before I do that, I'm going to real quickly look at it to just check and see that it doesn't eliminate a variable if I add them together. So let's look at this, and if you add these together, I get 2x and 5, I get 5x. What is a negative y and a positive y? Well, those are canceling each other out, aren't they? They're 0. A negative 4y and a positive 4y makes a 0, so they're gone. And this, if I add it together, is negative 15. So I have eliminated the y. And that gives me the opportunity to just solve this. I can solve 5x equals negative 15. Divide by 5, divide by 5, x equals negative 3. Then when I want to figure out what y is, I just put it back in. So let's pick the first one. Let's say 2x. And instead of x, what am I going to put? Negative 3 minus 4y equals negative 18. So that's negative 6 minus 4y equals negative 18. Move the negative 6 to the other side. That's positive 6. Negative 4y equals negative 12. Last step, last step, last step. Divide by 4. Negative 4. Y equals 3. My solution is negative 3, 3. Okay. But I'm going to check this first before I go too much further. Now let's look at this next one. When I add them together, nothing cancels. This would be 18, this would be 9y, this would be negative 18x. Nothing cancels. So this won't work. But I do have this thing over here. What if one of them was negative? Then it would be easy to do this, wouldn't it? So how about we just multiply everything in this first equation by negative 1. So negative 1 times negative 9 is positive 9. Negative 1 times 3y is negative 3y. Negative 1 times 3 is negative 3. So now I write the next one down. And now when I add these two together, 9x minus 9x, that's canceling it out, isn't it? So 3y is equal to 12. Last step, last step, last step. Y equals 4. So I had to change it by multiplying every single piece of it by a negative 1, and then it began to cancel. So this is a little like a puzzle in that you have to figure out what the steps are. All right? So let me get this next one up here. Well, now nothing's the same. If I add it together, nothing's going to cancel. Nothing's the same. So I'm in a little trouble here. But I did notice that this one is positive and this one is negative. And I thought, you know, if I multiplied everything here by a 6, what would happen to the x's? Well, let's see. If I multiply every single piece of this by 6, so 6 times x, 6x. 6 times negative 2, negative 12y, and 6 times negative 5. That's negative 30, isn't it? And now I'm just going to write down the other one. Negative 6x minus 4y equals 14. Now that I multiplied this top one by 6, look what happens right here. The negative 6x and the positive 6x, now they do cancel. So I can still finish my work, and this is going to be 16 negative, and we're going to divide both sides by negative 16, and y equals 1. But I had to figure out how to multiply one of the equations so that there was something that disappeared. Now let's look at one more that is a little harder because nothing is the same. I can't multiply just this one by 2 or this one by 3. It still won't work. I'm going to have to multiply both equations. Now, there's 2 ways to do it, but I'm going to take the first. I want to figure out how to multiply so that the x's disappear. Well, if you think about it, if I multiply everything in this first equation by 7, and I multiply every single thing in this equation by 2. Do you see where I got 2 and 7? I got them right there. So let's see what happens. 7 times 2x, 14x. 7 times 8y, what is that, 56y. And 7 times negative 24, okay, negative 168. Now when we are doing this kind, we generally start talking about much bigger numbers, but they'll fall away pretty quick. 2 times negative 7, negative 14x. 2 times negative 5, negative 10y. 2 times negative 8, negative 16. So this time, when I add, do you see how the 14x and the negative 14x, now they cancel? Because I multiplied by the opposite. I multiplied all of this by 7. I multiplied all of this by 2. So that the x's canceled. Now I have 46y is equal to negative 184. Divide, divide, divide. Y equals negative 4. Now I do want you to think about this. I could do the exact same problem. And let's think about this. 2x plus 8y. And let's look at what would happen if I did the y's. Instead of the x's, I did the y's. Well, that's an 8, right? So I'm going to multiply all of this by 8. And this one I'm going to multiply by 5. Now I'm not going to multiply by negative 5 because I need the negative to stay there. And you'll see that in just a minute. All right, so let's start working. 5 times 2 is 10x. 5 times 8 is 40y. 5 times negative 24, negative 120. Now I'm going to do by 8. 8 times negative 7, negative 56x minus 40y equals negative 64. Okay, because I multiplied this one by 5, because see, here's the 5, and I multiplied this one by 8, because there's the 8, I now get rid of, I eliminate the y's. 40, negative 40. And now I can go ahead and finish my problem. But 46x is equal to negative 184 divided by negative 46 divided by negative 46. X equals 4. All right, so I have a choice to make on to which way I want to do it. And you're probably kind of an efficient idea is thinking about, okay, I don't want the biggest numbers. Let's do the smallest numbers possible, so we can figure out, do I want to delete the x's, or do I want to delete the y's? So that's the decision that you're making when you get to the more college-bound readiness.